All right. Unit 2.1, this is the first of Unit 2, which is all about parallel and perpendicular lines. So as we get more into those, we're going to have to discuss lots of different angle relationships within those parallel and perpendicular lines. So in order to do that, we have to first start with our angle pairs. So that is the first section, 2.1. If you are somebody that would like to follow along with a note sheet and you have a printer at home, these notes are available on Google Classroom as well. So you can print it out and follow along as I go through this. So let's get going. So we have 5 different types of angles that we're going to talk about today. And I'm going to draw you an example of each and just kind of talk through the specifics for these. So first up, we have adjacent angles. So adjacent angles, what's important about them is that they share a common side and vertex. Okay, so if I'm looking at a picture of these, here's one angle, here's another angle, right? I'm going to call this angle 1 and angle 2. And again, what's important is that they have this side in common and this vertex in common. Okay? So another way to describe adjacent that we'll talk about is really just next to. So adjacent or next to each other. Okay. Secondly, we have vertical angles. So vertical angles are angles whose sides are opposite rays, right? We have rays going in opposite directions. And important about them is that they're always congruent. So in this picture that I have here, right, you always kind of want to look for this X. Anytime you see an X of 2 intersecting lines, you're going to think vertical angles. So I have 1 and 2. Those are a pair of vertical angles. I have 3 and 4. Those are a pair of vertical angles. And again, they're always congruent. So angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Okay, those are vertical angles. Next, we have complementary angles. So important to know about complementary is that it's 2 angles that add up to 90 degrees. That's the key here. So these angles, oftentimes you'll see them as adjacent angles, right? Or again, next to each other. So you'll have a 90-degree angle, which you might see this little box. Again, that tells us it's 90 degrees. And then we have 2 angles there. So the measure of angle 1 plus the measure of angle 2 has to equal 90 degrees. However, these do not have to be adjacent. So this one could be, let's say, 47 degrees, right? And then this one is maybe 43. And together, those still add up to 90 degrees, but they do not share a side, right? So again, the difference, these are adjacent because they have this side in common. Although these look like they're next to each other, they're not actually touching. So they could be anywhere on your page, and as long as the 2 numbers add up to 90, we're good for complementary angles. All right, supplementary is similar, except now we have 2 angles that add up to 180, okay? So again, same thing. They can be next to each other. Supplementary 180 is a line. So they might look something like this, where we have 1 and 2. And again, we know because they form a line next to each other that those 2 add up to 180. We could also just have 2 angles. Let's say this is 60, and then we have a 120-degree angle, right? Those add up to 180. So again, even though they're not next to each other, they're still supplementary because the values together make 180 degrees. It's a common mistake to get those 2 confused. I always think the way I remember is that complementary C comes before S in the alphabet. 90 is smaller, so C is 90, S is 180. I know one of the ways Mr. Cost thinks about this is he makes this C for complementary into a 90, right? And then supplementary we can kind of easily make into a 8 for 180. So hopefully one of those tricks works for you. Okay, and then lastly, we have a linear pair. So again, we have two angles that make a line, right? So that's the important thing. Um, Two important pieces here. They're adjacent and they form a line. So they have to have a shared side, right? That's what adjacent means. And then they form a line. So because they form a line, we're going to look at this postulate that says if two angles form a linear pair, then they are supplementary because a line by its nature is 180 degrees. So if I have two angles that form a line, right, and we know that this whole thing, this is 180, so they have to be supplementary. Okay, so there are our 5 different angle types and then one additional postulate. And so now we're just going to do some examples to show you how these would show up, what you might see. Okay, so first up, we have this picture over here. We have some angles measured, right? These are written out, but then there's some blank ones too here. So what I would suggest when you're doing something like this is let's see if we can fill out the missing information first. Right, so can I find a measure for this angle? And can I find a measure for this angle based on what's given to me? So let's look at that. Anytime you have a line, that's going to be helpful to you. So this line here, again, we know that lines have to be 180 degrees. So if this whole part is 180, this is angle addition, right? We've done this before. And this part right here is 118. All I need to do to find what's missing is take 180 minus 118, and that gives me 62 degrees. Okay, so the measure of angle CFD is 62 degrees. Now, I can do that same thing. I'm going to erase some of this. I'm going to leave this 62 as best I can. And I want to find now this one in green, but I can use the same idea. I have a line right here, right? So I can figure out this piece because, again, this whole thing has to be 180. So I know I have 62. I know I have 28. If we add those together, we get 90. If I take 180 minus 90, right, what's left is this missing angle, and that's 90 degrees. So I'm going to put that little box there so we know that that is a 90-degree angle. All right, so now I have everything labeled. I have all my angles. I have 62 right here. I have 118. I have 62, 28, and then 90 for this angle. That's just going to make the rest of this a little bit easier. Okay, so again, let me clean up my picture before we move on, because I'm going to keep writing on this, and it's just going to get more messy. Let's just move this. Okay. All right, so name a pair of adjacent angles. Again, adjacent just means next to, they have to share a side. So let's say I pick this as my shared side. Then my two adjacent angles are going to be angle AFB, which is this angle here, the 90-degree angle, and angle BFC, which is this one here, the 28-degree angle. And again, they share that side, FB, and if you notice in its name, right, they both have FB in their names because that's the shared side that they have. Okay, so they have to have that in common. All right, a pair of complementary angles. Well, again, all we know or all we need to know is that these two angles add up to 90 degrees. So, well, don't 62 and 28 make 90? So I'm just going to say angle AFE and angle BFC. And that's a good example because, again, they're not next to each other, which they don't have to be. But if I take those two values together and add them, that gives me 90. We could also have this pair. So we could also have this one, the 28 degrees, with this 62. And that would be fine also. Okay, a pair of supplementary angles. Now, supplementary has to make 180. So, again, can I find two values that add up to 180? Well, 62 and 118 make 180. So, let's say I have angle CFD and angle DFE. And one thing you should notice is that if I look at both of those angles together, they're going to form that line, right? They have their shared side, so they are adjacent. But if I take their two measures, they add up to 180, so it's perfect. I could have different answers there. Again, this is just one option. Okay, pair of congruent angles. Congruent angles means the same measure. So I have 62 and 62. If I didn't take the time to figure out these measures before, well, these are what we call vertical angles, right? So here's my, here's my X that we talked about. And so this angle has to be the same as this angle. Okay, vertical angles are always congruent. We took the time to figure out the measure, so we know that this 62 angle and this 62-degree angle are the same. So angle AFE and angle CFD. Okay, vertical angles, we just talked about that, so that's going to be the same answer. And then a linear pair we also already found, right? Because we said the two angles that we used for supplementary, those form a line, so I'm going to just write that same answer there. Angle CFD and angle DFE. Okay, we will do some more examples like this in class together tomorrow. Okay, next example, right? First thing you should notice, this is a line. So a line is 180 degrees. All we need to know, we don't know that they're congruent from the picture. They don't look congruent, but we're going to set them up so that together they equal 180. Okay, so take your like terms, 2x plus 4x, draw your line down the middle, that's 6x. 24 and 36 is 60. Again, if you need to have a calculator next to you, totally fine to do this. Okay, so same side, we add them. Now we're going to solve. So I subtract 60 from both sides. Divide by 6. So x is 20. Now again, it's not asking for x. It's saying what's the measures of KPL, LPJ. That's those angles here. So I need to plug 20 in. So, oops, I'm on the highlighter. I don't want that. So 2 times 20 plus 24 is 64. So that's this one here. And then 4 times 20 plus 36 is 116. So that's this one here. And then just to double check, if I take 64 plus 116, they should add up to 180, and they do. Okay, so three-part answer there. First, find x, use that to plug in to find these values here, 64 and 116. Okay, we've talked about this a little bit, but just to revisit, an angle bisector is a ray that divides an angle into two congruent angles. So AY is my angle bisector, right? And then this angle is the same as this angle, okay? Endpoint of that ray is the vertex of the angle. So just an application of using what an angle bisector, what you might see, it is telling you that GH bisects FGI, which is this big angle, right? FGI. So I know that this one has to be the same as this one. And those tick marks are there. Hopefully you see them right here. Arc marks. So we could go off the picture. Sometimes the picture isn't enough. Here it would be. So if we have congruent angles, congruent just means the same. Another word for same is equal. So I set them equal to each other. Draw my line down. I have opposite sides now, so to put things together, I actually need to subtract. So I get -3 equals x minus 14. Don't worry about that negative because I'm going to add 14 over here. -3 plus 14 is 11. So x is 11. So that's part one, solve for x. Then again, I'm going to plug in. So FGH, 3 times 11 minus 3, that gives me 30. Because I know this is an angle bisector, I actually don't even have to plug it in here because I know these are going to be the same. If I want to double check my answer, I could, but that's going to equal 30 also. And then FGI, the whole thing, I would just take 30 plus 30, right? Multiply it by 2, 60 degrees. So this is 30, this is 60. Okay, and so the rest of these are extra practice if you want to give them a try before class tomorrow. If not, we will do some of these and some more stuff like this in class tomorrow.